Welcome everyone to my session. This is all around developing apps for small screen, low memory wearables. So just before we get into the actual content of this presentation, I would just like to give a quick introduction of myself. So my name is James Swinton-Bland. I'm the Global Developer Relations Lead for Zebra Technologies. I've been with Zebra for around 4 years or so. I've been in this role for about 6 or 7 months now. So it's essentially my job at Zebra to define our developer relations strategy, which is one of the reasons that we're at this event, we're doing this talk, and we also have our sponsored booth. So in terms of training and experience, I have 7 years of Android development experience, so that's kind of where my speciality lies. And I've held previous roles both as an Android developer and a developer advocate as well. So I think I have a fairly good understanding of both sides of the coin in that sense. As I mentioned, we're a sponsor of this event, so we have our sponsored booth. So I think I may have seen 1 or 2 of you at the booth already today. But if you haven't, please do feel free to come along and stop by and have a chat. We've got plenty of nice giveaways and swag, so our little plush toys and some socks. We're also running a competition where you could be in for winning a GoPro for providing some feedback on our technical documentation site as well. So please do come along and have a chat with us. We'd love to tell you more about what we do. So that picture there is me on the right. I think I look pretty much the same, maybe just a few more pounds this year, even wearing the same shirt. But you can connect with me on Twitter at James Swinton-Dev, and you've got my email address and LinkedIn there. I may regret putting that email address out publicly, but we'll see. So before I get into sort of the nitty-gritty of the presentation, I just sort of wanted to give an overview and sort of set the tone for what we're going to be talking about for the next 15 minutes or so. So there are, plenty of different wearable devices, and that's why I've tried to keep the title of this talk relatively vague. I'm not going to focus in on any particular framework or operating system. I'm going to try and keep it high level. So, in terms of wearables, I'm sure we're all aware of Wear OS from Google. This is probably the most popular platform or operating system, however you want to term it. But it's not the only one that exists. So there's plenty of proprietary operating systems for wearables as well. So I've got examples here of Huawei and Garmin, who all have their own proprietary OS for various different reasons. And I'm sure there's plenty of other proprietary operating systems that we could discuss as well. And then, of course, which is kind of the reason for doing this talk, is our own device that Zebra create called the WS50, and that runs on Android open source platform. So the idea of this slide is just to say that there are a lot of general considerations to be made when developing for wearables, and it's not just about what sort of platform that you develop on. So just before I get into a little bit more detail about some of the considerations that you want to have in mind for developing for these wearables, I just wanted to touch a little bit more on our own device, the WS50. So obviously the company pays my salary and my ticket to these events, so I have to show these slides in here, but I do think this is still quite an interesting product and has some unique features. So as I mentioned, this is running full Android and AOSP, so pretty much anything you can do on a mobile device that doesn't require Google services, you're going to be able to do on this wearable device. Comes with Wi-Fi, Bluetooth, and NFC connectivity. So we don't have cellular connectivity that some of the higher-end consumer devices may have, but we do have internet connectivity nonetheless. Bluetooth for hooking up to our Bluetooth headsets or speakers, and then NFC as well for doing tap-to-pair and things like that. So it comes with 1 GB of RAM and 8 GB of flash, so you are very limited in what you can do. I think this is pretty consistent across wearables in the ecosystem, and that 1 GB of RAM is also used by the operating system as well, so what's available to you is even less than that. And again, that's pretty consistent in terms of the wearable ecosystem. Has a 2-inch touch display, so our device has a slightly larger display, but a lot of the considerations that you make for this device, again, also apply to consumer devices. Comes with a removable battery that you can hot swap, so that means you can pull it out and put it back in, replace a new battery, and the user won't be interrupted in their workflow because there's a backup capacitor in the device. It's fully ruggedized, as all our devices are, to survive a 6-foot drop. And of course, we have multiple data capture options, so you can use cameras and scanners inside the WS50 as well. We have push to talk, which enables communication, and a common power and comms interface to multiple mounts and accessories. So in the bottom left there, you can see our finger scanner configuration, so it sits on your fingers. We have a back of hand mount as well, or like a glove mount, and then we have a wrist mount as well. So we have all of those available at the booth, so if you'd like to see more of this device and see it in action and try it out, please do feel free to come along. We'd love to show you more. So now let's get into more of the core content of this presentation. So the first thing I want to start on is some of the key and fundamental differences between mobile and wearable devices. So this list is far from exhaustive, but I've tried to pull out the key considerations that you need to make. So depending on what platform you're developing for, be it a Wear OS or a proprietary OS or even AOSP, these watches or wearables, they're going to use specific APIs depending on the platform that they're running on, and that's something that you're going to need to consider. The Android mobile ecosystem is, of course, fragmented in terms of the devices you have, but the API set is fairly consistent. With the wearables, you're going to see significant differences depending on which device you're trying to target, and that's something to bear in mind. UI and UX, so this is a very obvious one, but the UI and UX is fundamentally different from a mobile device. So some of the design paradigms and the fundamentals that you may know of when developing for mobile, you can kind of throw a lot of them out the window, and you need to completely rethink things from a wearable perspective. Functionality as well, so mobile devices, they are used for so many different things. I'm sure we all know that. When it comes to wearables, they're used for very specific use cases. So the consumer devices, are typically going to be used for things like fitness tracking, maybe navigation, as well as music as some common use cases. Whereas, our devices, our wearables will have even more specific use cases in the enterprise space, and we will touch on that a little bit later. So the functionality is very specific when it comes to wearables. And then finally, navigation as well. So when navigating in a mobile app, we all have our paradigms and the way we like to do things and the sort of the standard procedure. Navigation on wearables is certainly a lot more cumbersome for the user. So when we're designing our flows to access different pages on our apps and things like that, we need to be much more careful in how we design those and make sure that they're much more efficient and practical for the user. So the next section here is sort of touching on some of the key principles of wearable development. So a lot of these notes are taken from the Google's advice and Google's documentation. Obviously, they've got great experience with their Wear OS software. But the main thing really for watches is developing for critical tasks. So rather than creating a full app experience as you may traditionally do, you want to focus on one or two specific tasks that the user can complete on that wearable, and then, if needs be, navigate them back to their fully fledged mobile device. So the examples here are just Google Pay and the music apps, but you can see there that they have a much more toned down user interface, and they sort of restrict what the user can and can't do, and it's just very simply selecting a card or moving forward or back in your music or pausing it. The next big consideration you need to make is optimizing for the wrist. So obviously, a mobile device you hold in your hand, a wearable you wear, well, that's obviously the name. So in order to avoid ergonomic discomfort or arm fatigue, you want to be able to help users complete tasks on their wearable within a matter of seconds. You don't want them sitting there staring at their device, holding their hand in the air for an extended period of time. That's going to be a terrible user experience. So making sure to optimize for the wrist is important. Working offline, so again, I mentioned the WS50 that we produced doesn't come with cellular connectivity, so there's going to be a lot of times where the device isn't going to be connected. That's also true for a lot of the consumer devices as well. Some of them, the higher end ones, do come with cellular connectivity, but of course the hardware there is going to be toned down significantly as well. So you need to be prepared and develop against the possibility of slow connections or even offline use. So cold starting as well. So again, obviously, because you've got to put so much hardware into such a small package, the processing power is going to be significantly diminished. And that can mean if you're launching your app from a cold start, or the user is launching your app from a cold start, there could be a slight delay between launching that app and actually being able to do something with it. So it's good practice in a wearable to include some sort of splash screen with your own company's branding in order to give them a more seamless experience while the watch processes and gets your app ready and running. You also want to leverage gestures and haptics as much as possible. So this kind of touches on the changes in navigation functionality on watches. But users will interact with wearables in a fundamentally different way. So you really want to leverage all of the resources that are available to you to be able to provide feedback to that user and allow the user to navigate through your device. So obviously gestures exist on mobile devices, but they're more of an optional thing. Whereas with wearables, I'd say that's something that you fundamentally want to consider. So now moving into sort of some of the UX and UI touch zones. So this is quite a meaty slide from a text perspective, but there was a study conducted by MIT Touch Lab, which is basically studying human fingertips and the mechanics of tactile sense, which sounds like a very fun industry to work in. But they found out that a human fingertip on average is around 8 to 10 millimeters in diameter, and that's something that developers want to keep in mind when they're developing or designing their UI screens, because obviously there's a possibility of overlap and tapping errors with adjacent touch zones. So these minimum hit zones and touch zones are very specific to our Zebra device, but that's based on basically the size of the device and the resolution. You could quite easily take this research from MIT and apply that to various other consumer wearables in the market. So I won't read out exactly what our recommendations are, but that little image on the side is a to scale mock-up of our wearable and what an average human fingertip would look like on the display. So you can see there that a significant amount of space is taken up by that user's fingertip, and that's something you want to bear in mind when you're designing these screens. So based on this research, we've kind of put this graphic together. So again, this is very specific to our device based on our dimensions and things like that. But you could very easily replicate this with a consumer device, just replacing the values that we've used for the size of our device with the respective device that you're looking to develop against. So the idea of this is just to sort of showcase, the less items that you have on your wearable screen, the better. The more simple you can make things for the user, the better it is. As soon as you need to start displaying complex or intricate information, then your user is going to start seeing a decrease in their experience with your device and your application. So this next slide kind of just puts into perspective that previous slide around touch zones. So the key things that you can see here are the strong use of colors to identify things so that users intuitively can grok what's going on with a quick glance at the device. So, green for positive, red for negative, orange for, maybe or warning. Leveraging icons is also a very good thing to do. If you're trying to plug in a lot of text in here, it's going to be hard to make that legible, and it's going to be much easier for users to intuitively see what's going on by using icons. If you do need to display a lot of information, which the last image there is trying to show, then you certainly can do it, but you want to make sure that where the user interacts with your application still has significant amount of space on that screen so that you prevent touch overlapping and any errors that may occur like that. So now let's move into battery and power management. So again, obviously putting all of that hardware into such a small amount of space is, it's going to have an impact on the amount of battery life and the amount of processing power that your device has. So there's some things that you want to keep in mind here. So the display going to sleep is one of the main things that saves battery on devices. That's true for mobile devices as much as it is for wearables. So you want to make sure that your app doesn't do anything that prevents that device display going to sleep, which is very much similar to this second piece of advice, which is not obtaining wake locks. So obviously one of the main things that can stop a device display going to sleep is if you acquire a wake lock, which is something that you can do on wearable devices. You really want to avoid this unless it's 100% necessary. There are certain fringe use cases where you will have to acquire a wake lock, and there are times where that's okay to do, but you need to have a really good think and debate about whether that is something that your application genuinely needs. Testing doze mode as well. So another key feature of the Android-based devices, at least, is the doze mode functionality. So your app being put to sleep when the user's not actively using it. You want to make sure that your app gracefully handles the entering and exiting of doze mode, which is even more important on a wearable than perhaps it may be on a mobile device. And you want to make sure that it manages its memory consumption as well based on that. Then finally, sensor management. So this is another key thing that you want to consider when you're developing for wearables, is to only use the sensors when you really have to. But of course, there's a lot of use cases where you do have to use your sensors, be it a fitness tracking app or a navigation app, something like that. So when you do need to use your sensors, there's a few key things to keep in mind. You want to use those sensors in batch mode as much as possible. So rather than constantly polling or getting reoccurring updates from those sensors, do them in batches so that you're using less battery and power. You want to monitor the screen state as well. So if the user's not actively engaged in your application, do you really need to use these sensors? And if you don't need the sensors when the user's not interacting with your app, then unregister those listeners promptly. And that would be, when the application goes off into the background, or making sure that you release your resources properly when your application is killed on the device, be it by the user or by the internal memory management of the particular operating system that you're running on. So this kind of dovetails kind of nicely into the memory management section as well. So as much as we have limited battery and power resources on wearables, we also have very little memory as well. So our device with 1 GB of RAM, around about 650 meg after the OS is taken into consideration. So it's very important to be very considerate about your memory. It's like going back to the 90s or something when RAM was a lot less widely available. So the key thing to do, I think this is the main one to take away from here, is just minimize the number of processes that are running on that device at any one time. So you can't really manage what the user is doing with other applications on that device, but you can certainly manage what your application is doing. You really want to limit those foreground processes or always-on processes as much as possible. Again, there's going to be use cases where that's unavoidable. If you're a fitness tracking app and the user goes on a run, then you're going to have to keep that process alive in the foreground, but you really need to have a strong consideration here about whether or not you actually need that. Next is simple workflows. So your application will have several workflows, I'm sure, but you only want to handle 1 or 2 tasks within that workflow. So that workflow needs to be broken down made as simple as possible, and that kind of ties into this second point here, where each screen inside of that workflow should only focus on a single task. So if you have 2 tasks in your workflow, then you should also have 2 screens in that same workflow, and that's just to make sure that the UI is simple as possible. So every screen should have a relevant task and only 1 task per screen. And then very much in the same vein as the previous slide, you want to make sure that you manage your sensor usage as much as possible. So it won't just have an impact on your battery life, but it will have an impact on the memory in the device as well. So moving on to one of the penultimate slides here, so around optimizing for the wrist. So as I mentioned towards the start, it's very important to make sure that users can interact with your application in a simple, quick, and efficient way. Ideally, they're going to need to be able to complete the interaction with that wearable device in literally a matter of seconds. If they're having to do anything more than, say 20 or 30 seconds of holding their hand up like this with their wrist pointing at their face, they're not going to be very happy with that. So you want to make sure that they can quickly complete the task that they came to do on that wearable, and that goes back to using colors and icons and large buttons and things like that to make things very intuitive. You essentially want to keep things as simple as possible, which tails nicely into navigation as well. So I mentioned that navigation on wearables is much more cumbersome. You don't have as much screen real estate. So again, you want to make that as simple as possible. Don't overload your application with a ton of menus. Don't have long scrolling endless pages or having to jump back and forth between screens. You really want to condense everything down into its most basic form. Convenience and relevance, this is kind of similar to the last couple of slides here, the last couple of points on this slide. But whatever the user is doing on that wearable, it has to be relevant to that wearable. If it's something that they could do on a mobile device more efficiently, then use the mobile device instead. Just because you have the option of putting it on the wearable doesn't mean that it's necessarily the right thing to do. And then I think this last piece of advice is good advice just in general, but when it comes to wearables, it's even more important. So you want to test, test, test. You need to optimize your user interactions, your usage of memory, and also your usage of the battery. I think, mobile devices are ubiquitous now. If someone goes in, you give them a mobile device, they're going to be able to pick that up and run with it essentially and not need any hand-holding. I think wearables are still newer to the market. They're less intuitive. People have less familiarity with them, and that means they're all going to interact with those devices in slightly different ways. And you need to do a lot of research to understand what those interactions look like and how your application should handle those interactions. So the key here is just to test, test, test. Okay, so finally, I just wanted to sort of come back and loop around and finish on enabling enterprise use cases. So obviously, Zebra are an enterprise company, and we've developed the WS50, our wearable device for enterprise use cases. So we think this is particularly well positioned for the use cases you're about to see, but I think it could also apply to consumer devices as well if you do work in that sort of industry. So one vertical that we see there being a lot of benefit of our device is around warehousing and being able to do item sorting. So obviously we have integrated scanners on our device, which is sort of a USP from our point of view. But you can use the device to provide line-of-sight instructions to workers on correct bin locations, so helping warehouses sort their items more quickly and efficiently. This next example in warehousing around maintenance is more about sort of bidirectional communication and sending and receiving alerts. So essentially like a modernized beeper that you might have seen in like hospital shows or something. Again, back from the 90s, this is kind of just a modernized way of doing that and providing additional context to the user. Transport and logistics, so loading and unloading. Again, this is focused on high-intensity scanning, but being able to leverage, audio, haptic, and visual feedback to indicate to the user quickly whether or not there was a good or a bad load, for example. And then finally, retail task management. So this is an example of communication and sending tasks down to the user, so pushing messages to the user, letting that user confirm receipt of the message, and then subsequently the completion of the task. So I think I've got through quite a lot of content there in a fairly short amount of time. So I think I've got a couple of minutes left for any questions. So please feel free to raise your hand. I'm sure we could get questions out. Otherwise, come and see me at the Zebra booth and we can talk, one-to-one in a little bit more detail. So thank you very much.